Hello, welcome to my lecture on nuclear energy as a sustainable, safe, and even renewable energy source. So hopefully you will enjoy this very much, and let's get started. So to start off with, public opinion and bias. Social researchers have found that a person's worldview actually affects their opinion of nuclear science and technology. That might sound a little strange, but they've also associated it with this birth defect coming with atomic war. So that is something that might sound familiar in terms of the political spectrum that we have today on COVID in terms of policy, politics, and science. The social researchers have gone even further and started to point out that tribalism is an opinion and that tribalism itself can lead to terrorism. Why is this interesting? Well, it's not just because it leads to terrorism, but it speaks to things like why you think that your favorite team is the best or the school that you went to is the best and so forth. It's this particular need of us to believe that we see things the right way and that to associate with other people that agree with our look or the way that we look at things. And they've actually coined this phrase that it's become part of the ethnography to be anti-nuclear once you've adopted this worldview. So let's actually look at the accidents and see what kind of safety record we actually have. When it comes to 3 Mile Island, that scared a lot of people, it really terrified them. But when you look at the actual dose that came from that, it was negligible. So that the dose from the entire release was about 3 daily background doses. So what you got from a daily background, that about 100th of a millisievert, it was about 3 times that, the entire release. That's what the average member of the public got. So it was negligible. It was just an extremely small dose. It terrified people so that the only observable health effect was physiological. The stress-based fear is what came from that, but it cost an enormous amount of money, even though the total dose was comparable to background on a weekly basis. Now, Chernobyl, there's a good example of where people really got hurt in a bad way. There were statistically significant increases in cancer, leukemia in children, and obviously that hurt a lot of people. On the order of about 1,000 people so far, you could say that that's been what we're confident was due to cancer from Chernobyl. However, now we start to get into my thesis. When it comes to the psychosomatic effects of Chernobyl, there's been a larger statistically significant increase in suicides from Chernobyl, and that's due to this radiophobia, this belief that anything that bad happens to you was because of this low-level radiation. And there's a stigma associated with that, so that more people can now be said to have died from radiophobia from Chernobyl than actually had died from the radioactivity that was released. That's very profound, that the fear is killing more people now than the actual radiation as a result of Chernobyl. All right, well, let's look at Fukushima. So I trust everybody that's watching this, they do trust the International Panel on Climate Change because it was an expert panel put together by the UN. But what if the UN put together a panel and looked at Fukushima? And then to add to that, what if they said there's no discernible difference from natural rates and effects? In other words, no measurable medical effects to any of the Japanese public. Would you believe that? Well, now, if you don't believe that, maybe you can associate with people who deny climate change, because UNSCEAR did make that change. And not only did UNSCEAR, the World Health Organization made that claim. And all the expert panel, the expert review papers, they also made the same claim. The dose was too small from all of the radioactivity released by Fukushima. Yeah, and here's some of these review papers that you might want to look at. So the social scientists have also noticed that nuclear waste is actually another terror phrase, like Chernobyl or Fukushima. The word in and of itself ends all discussion for many people in terms of it becoming this ethnography, that it's just a statement that this is why nuclear is bad and wrong and possibly even evil. It's just that term, nuclear waste, with or without any other technical basis or discussion. It ends the discussion. So how bad is the problem, this nuclear waste issue? So here's a great analogy. Since the 1970s, 20% of all of the US electricity came from nuclear energy. And all of the spent fuel from all of that electricity, I mean, that's many, many decades worth. It would not fill up a single football field above 10 feet high. So oh, they should say 10 feet. It's 3 yards or 10 feet. So I actually have a misprint there. Anyway, the point is, it's just so dense in energy that it does not make a whole lot of waste. Now, it does make spent fuel, but the amount of energy that you get for waste is just phenomenally huge. The energy density is just enormous. So here's not quite an aside. We're still talking about nuclear waste, but we know that there was a natural nuclear reactor that occurred in Gabon, Africa, there in Africa. And that was because when you look at the isotopic abundances of certain elements, they weren't what we found in nature. If you look at what we find in nature, it's very different than what we found at Oklo. And what we find at Oklo is a superposition of the fission and the natural. When you take out the natural, you see that the actual distribution of these isotopes were from fission. In other words, around 2 billion years ago, the radioactive decay that goes forward went backwards. So that uranium-235, which has a shorter half-life, the fissile isotope, it grows backwards in time much faster than the fissionable uranium-238. So around 2 billion years ago, this uranium would have had comparable enrichment to commercial nuclear fuel. If you went back about 4 billion years ago, it would start to become high enriched uranium. And the point is that this actually did go critical, and the fission product stayed. The geology was sufficiently stable that for 2 billion years, the fission product stayed in the ground, meaning that technically, once we have good geology, we can have geological disposal that's safe. We take the uranium out of the ground, we fission it, and then we put it back in the ground so that it can heat the earth in the same way that it was doing before. It just speeds it up. So this is a great example for how we can be confident that we can have safe nuclear waste disposal in a geological repository. So the social scientists have also found that Yucca Mountain, that's another statement that has started to become part of this tribalistic ethnography. And here's some of the research papers. They've even said that it's in the New York Times that they have this overt bias in them when they're talking about it, that they only talk about things that are negative and not things that are positive or things that are factual, just people's feelings, and focus on the feelings. So now let's get more to my thesis, and that is, why is it such a great thing in terms of environmental friendliness, in terms of environmental stewardship? If you look at the total amount of materials, the concrete, the glass, the steel, the aluminum, for all of the different energy sources, and you take how much material is required for the life cycle of these and divide it by the total terawatt hours, in other words, how many materials per how much energy do I get out? Nuclear is the smallest, even when you compare it with all of the renewables. Now, this is extremely profound in that if you want to be environmentally friendly, think about mining, think about milling, think about waste, think about the footprint for deployment, think about all of the infrastructure that's required. These traditional renewables have the largest environmental impact in terms of materials. The energy that's required to make concrete is huge. The energy that's required to make steel is huge. And right now, the majority of that is coming from fossil fuels. And that's what we're making right now, are these very low density energy supplies when we do hydro, wind, and solar. So nuclear, just because it's got that massive energy density, remember, it's about 200 million electron volts per fission, whereas when you're talking about fossil fuels, it's on the order of about an electron volt per atom rearrangement, somewhere on that order. So many millions of times more dense than fossil fuels. And so that's where you get this from. Even though it still takes a lot for nuclear, it's just got an enormous energy density. Now, this one's interesting because you can see greenhouse gas emissions is probably no surprise. Nuclear really has none in terms of comparing it to the fossils. It's the same as the traditional renewables. I think this is interesting because this classification here by the US Department of Energy says that geothermal is renewable, but nuclear is not, even though they have the same energy source, right? Geothermal, the vast majority of that is from the radioactive decay of uranium and thorium and potassium, the primordial radionuclides, and that's the same source for nuclear. And so geothermal is listed as renewable, but nuclear is not. But I will tenet that nuclear actually is renewable when we come to the end of this. So even the International Panel on Climate Change, they recognize this. This was their graph from their report, where they're showing that in terms of the greenhouse gas emissions, that nuclear is right there as low as you can get, just about. So they recognize that. Now, probably one of the biggest arguments that people come is that it's known that large amounts of radiation cause cancer. And so the argument there really is, well, how many people are dying from this? Well, if you just look at the accidents where you actually have a measurable known amount of deaths, per amount of energy, nuclear comes down to be the lowest in the sense that it's kind of like an airplane crash. Airline travel might be the safest, but when you have an airline crash, that makes world headlines, right? But when you have 50 people die every year on the highway in a state, that just makes the back page. And so the accidents are very, very clear in our memory because they're so profoundly emphasized in society, even though the number of deaths per amount of energy is incredibly small. Now, this does not include linear no threshold. In other words, if you cannot measure the death, it's not included. And linear no threshold allows you to kill people, even though there's not a measurable effect. It's down in the noise. It's not statistically significant. So that's what's being done here. Whereas with wind, when you're looking at wind, if you fall off of a turbine, you die. And there's an example over here where if you look at this report from a Greek wind farm, an extremely low death rate, but even at that low death rate for that low amount of energy, if you did the same thing for that year, this is talking about for the year 2008, there were no deaths from nuclear industrial deaths of any kind. And so if you scaled up, if you said this was an acceptable death rate, 4.4 times 10 to the minus 5, per 0.014 gigawatts in a year, if you scale that up to the amount of energy that we have in nuclear, there would have had to have been over 2,000 deaths from nuclear to get the same death rate as that wind farm when there was actually zero. So that's kind of showing you how you get this extremely small number. If you really care about death, if you really care about people being alive or not, nuclear definitely is in the front. It is definitely the way to go if that's what you care about, is people's lives. If you don't care about people's lives, then you can use one of these higher ones, I guess. So, and why do I say that it's renewable? Because it can be removed from seawater. Pacific Northwest National Laboratory and Oak Ridge National Laboratory, they've done some research. It's not as cheap as mining and milling, but it can be done passively. And the reason why that's so significant is that 9 times the annual electrical energy needs of the United States is just passively dumped into the ocean every year from erosion. All of the uranium that's giving rise to geothermal is being eroded and dumped in the ocean, just regularly recycling it through a natural cycle. And we could passively remove it using these fronds that can be either dangled from the surface or attached to the bottom, and you just go back and retrieve them and remove it. Now, it's not as cheap, again, it is more expensive, but if we did just use this as our source of uranium, it is as renewable as geothermal. And then finally, I would like to think, well, I would guess many, if not most people watching this think that medical treatment, healthcare is a human right. What I would like to point out is that, I'm just going to go this red bullet down here and finish it. Medical treatment doesn't make sense if you can't get to the doctor, right? It doesn't make sense if you don't have food, if you don't have water, if you don't have housing, if you don't have clothing, if you don't have all of these essentials, but all of those essentials require energy. And so the energy is essential to anything, to technology. I mean, without energy, without technology, a physician, all they could really do if they don't have a tool is poke you in the belly, or whatever, assuming that you would even be there with them. So all of that requires energy. All of those things are essential to life as we know it today in our society. So that brings me to the end. Hopefully you enjoyed this, and I will hopefully be on taking questions. So thanks for listening. Have a good day. Bye.